We all know large language models are amazing, right? But they've got this one huge glaring flaw. They lie. Not on purpose, but they confidently make stuff up. It's a problem we call hallucination. So for years, the big question has been, how do we catch a lie without having to constantly fact-check it ourselves? Well, let's dive into a groundbreaking new method that does exactly that, from the inside.
So an AI might tell you, with all the confidence in the world, that the French Revolution began in 1812. Now, we know that's wrong. It was 1789. But the AI sounds just as certain about this as it does about any real fact. And that's the core problem, right? It's what makes using these tools risky in really important fields like medicine or law.
So here's the million-dollar question. How can we tell the AI is making something up without having to go look it up on Google? How can we actually peek inside the AI's own process and find the clues that a lie is being born? That's the mystery we're going to unravel today. Okay, so to really appreciate how big a deal this new method is, we first have to understand the old way of doing things. You see, up until now, all the methods for catching these AI lies, they all worked from the outside in. They only looked at the final answer.
You know, the old ways were clever in their own right. One approach, which you see in tools like SelfCheckGPT, is to basically just ask the AI the same question over and over again. If you get a bunch of different answers, you can be pretty sure it's just guessing. Another way is to make the AI look up the facts in some external database.
But here's the problem with that. Asking multiple times is just incredibly slow. I mean, we're talking 5 to 20 times the normal computing power. And making it look things up just creates a whole other system you have to rely on. But the biggest issue? Both methods only judge the final product, not the AI's internal thought process that got it there. We really needed a better way.
And that, my friends, brings us to the really brilliant idea. What if we stopped looking at the AI's process as just a bunch of code, and instead saw it as a journey through a landscape of pure meaning?
Imagine this. As the AI is processing your question, moving through its dozens of layers, it's actually plotting a course through a vast, high-dimensional geometric space. Every single layer refines the meaning, taking another step on the journey. The incredible insight here is that the shape of this journey might tell us if the AI is confidently marching towards the truth or just wandering aimlessly into fiction. Now, this whole idea has a formal name, Layer-wise Semantic Dynamics, or, LSD for short. And what it does is pretty amazing. It totally ignores the final answer. Instead, it analyzes this semantic trajectory, the path of meaning, as it develops from the very first layer of the model to the very last. It's kind of like watching a detective follow a trail of clues to see where it leads.
So you're probably wondering, how does this actually work? Well, it boils down to a pretty straightforward 4-step process. First, it grabs the raw data from each of the AI's internal layers. Second, it plots all that data into a special map, a geometric space where we already know the location of the truth. Third, it calculates the shape of that journey. And finally, based on that shape, it tells you how likely it is that the AI is hallucinating.
All right, so now we have a map. We can actually see these journeys, and this is where it gets really, really cool, because you can see a huge difference in how an AI thinks about a fact versus how it thinks about a lie.
And wow, look at this. It's night and day. The journey towards a factual statement looks completely different from the journey towards a hallucination. The factual path is clear, it's direct, but the hallucinated one, it just wanders all over the place, like it's totally lost.
When the AI's on the right track, when it's dealing with a real fact, its path is, well, it's clean. It's smooth and direct. It moves consistently, step by step, getting closer and closer to the known correct answer in that geometric space. It knows exactly where it's going.
But a lie? Oh, that's a whole different story. The path is just messy. It's all over the place. It wobbles and veers off course, drifting farther and farther away from the truth. It's basically the perfect picture of uncertainty and instability. It's the geometric signature of being lost.
Okay, so the theory is solid, right? Straight lines for truth, squiggly messes for lies. But is it just a pretty picture, or does the data actually back this up? Let's look at the numbers. This is the moment of truth.
So the big question is, where does the AI end up? By the time it gets to its final layer, its last thought, how close is it to the actual truth? We can boil this down to a single number, an alignment score. A perfect 1 means it's a bullseye, while a negative score means it's pointing in the completely wrong direction.
And check this out. For a real, factual statement,
The final score is a super high 0.89. That is almost a perfect match. The AI's internal state is pointing almost directly at the correct answer. The journey was a success.
But what about the hallucination? A whopping negative 0.3050. Think about that. It's not just a little off target, it's literally pointing in the opposite direction of the truth. You just can't get a clearer signal than that.
So how does this new method stack up against the old school ways? Well, on a standard test, the previous best method, SelfCheckGPT, got a score of about 0.85. Pretty good, right? But this new LSG method, it scores an incredible 0.92. That is a massive leap forward in accuracy.
And if the accuracy wasn't enough, here's the real kicker: the speed. The old way was slow, remember? 5 to 20 times slower. LSD does all of this in a single pass. It's not just an improvement, that is a complete game changer for using this stuff in the real world.
Okay, let's take a step back for a second. What does this all actually mean for the future? Because this isn't just some cool academic trick. This is a big deal for how we build and trust AI going forward.
Honestly, what we're looking at here is one of the first real foundational steps toward building AI systems that we can actually genuinely trust. For the first time, we have a way to monitor for truthfulness from the inside out, to see if the AI itself is on a stable path.
And the potential here is just massive. Think about it. Real-time lie detectors for AIs that are helping doctors or lawyers. We could even use this geometric signal during training to teach the AI to be more factual from the ground up. It even gives us this incredible new tool to finally understand how an AI is thinking.
And this all leads to one final, kind of mind-bending question. We've just figured out a way for an AI to know when its own thinking is drifting away from reality. So the real question is, if an AI can learn to spot its own lies, can we one day teach it to never lie at all?